So that recording will be there. Okay, next we come to this one, Sawhorse projection. Now you see here, do you see this molecule? Hello? Do you see this molecule?
Yes, sir.
Yes, sir.
Here. Now you see, this is methane, ethane molecule. Here, this one is CH3 here, and then another CH3 is here. Okay, another CH3 is here. Now, what we find in Sawhorse projection, these two can be shown like this, as we see here. In this case, sorry. Here, this one of the CH3 group, let me just come with the pen. One of the CH3 group which is there is shown by 3 lines like Y. Okay. And other one is also shown by Y, but this Y is inverted Y. We can show it either inverted or this. This 3 hydrogen, and then you connect this carbon-carbon bond. But here you see this bond between these 2 carbon atoms. I can rotate it, right? I can rotate it without breaking it. It does not break. The bond does not break. These are called conformers. Okay, we'll come to conformers later on, more in details. So here this ethane molecule is shown by this projection formula called Sawhorse projection. And when we see the second one, the first one, suppose, first one, I write one CH3 group is here, just see, it is present like this. This is back side and this is front side. Front side. Okay, so the back side, this hydrogen is going down. This is coming on the right hand side, this is coming on the other side, left hand side. The other one is having the CH is above, then this is on the right hand side, this is on the left hand side. But if you see here, the position of these 2 hydrogen and this CH, these 2 CH and this CH, it is falling in the middle, right? It is falling in the middle. This one, this CH, and the other one is falling in the middle. Just see here. Where is that? This CH is coming, in the projection is between these 2. And everyone like this. This hydrogen is coming between these 2. And this one is coming between these 2. So this is what is called a staggered conformation actually. These are terms we use, this conformation. This is conformation. Now what happens, I can rotate this. What happens, somebody is giving scratch here and there. Don't touch anything with your pen. Now you see here, I can rotate this carbon atom here. Once it rotates, what happens? What I am doing, rotation of the backside carbon. Which is backside carbon? This one is rotated. So what will happen? This hydrogen is coming here, and other one will move here. As a result, what happens? This hydrogen and this hydrogen coming face to face. This one is, and this one coming face to face. This is coming face to face. And this is called eclipsed conformation. So here it will be something like this, eclipsed. This one is face to face, this one is face to face, like this. So this is called. Now here, what happens here? In this Sawhorse projection, we can show only 2 carbon at a time, not more than that. two carbon at a time. So one is front carbon, another is back carbon. So that is the limitation of this. And we can show the rotation of the bond also. So this is one type of projection called Sohaus projection. Next one is Newman's projection. Newman's projection, it is something like Sohaus projection. One of the CH3 group is shown like this. This is the front side CH3 group. And this one becomes the backside CH3 group. Backside is shown with a circle. Remember, backside of your eyes. When you put it, suppose this molecule you are putting in front of your eyes, this side is your front, this one is your back. So the backside is molecule is shown by this circular line with hydrogen is projecting outside like this. But the molecule, they are not disconnected, they are connected to one another by this carbon-carbon bond. In Sohaus projection, what happens? This bond is, you are showing the bond here. Between this carbon atom and this carbon atom, the bond is visible. But in Newman's projection, this bond is not visible. The connection between this carbon and the front carbon and the back carbon is not visible. As if this is just, it is hidden here. You have to understand that there is a bond. Okay? So, what we find here, now, here also I can rotate one carbon with the other. So what is that? Rotation is done. The backside carbon, what is backside carbon? This is the backside carbon. So when we rotate it, this carbon will come here. This hydrogen has come here, then this one. So this is called staggered conformation and this is called eclipsed conformation. I think you got it. Hello? Got my point?
Yes, sir.
Yes,
Okay. So,
yes, sir.
So what we have got these four different projection structure. One is your wedge projection. Next one is your, first one is your Fisher projection, then wedge projection, Sohaus projection, and Newman's projection. But now comes the most challenging one. That is how to convert one to the other. And here you have to be very, very careful. So next one is interconversion of it will get oh sorry. So interconversion of the projection structure. That means how we can convert one structure to the other structure. This is what is very, very important. And listen carefully. If you learn it, if you understand it, it is very simple. If you don't understand it, it is very difficult. I'm just telling you. Stereochemistry is very simple, I am telling you. But for that, if you miss your classes, I am telling you cannot understand this just by reading books. Otherwise also you don't read books, I know that one. But if you want to read books and understand it, it is very difficult. Unless and until you are a very, very exceptionally bright student. So if you attend class, if you understand it, it is very simple. And without attending the class, just reading books, I say it is very difficult. And
Sir,
yes.
In Sohaus projection, the rotation, which carbon we should rotate, front one or back one?
You can rotate anyone. Here it is, I have shown it just by rotation. Anyone can be rotated. You see, I can, this is eclipse conformation, right? I can rotate this is the front carbon I have rotated. I can also rotate the back carbon. Anyone. But which one you are rotating, that should be mentioned. You are rotating front or back side. Then, so that the position which is changing, you can understand. Okay. Okay, let us come here. Fisher to wedge projection. This is what. From Fisher projection, how to go to wedge projection. Let us see again what is how we write wedge projection. This is already being told. I'm just writing here again. Wedge projection is how to present this line. Suppose a molecule is bonded to by these groups A, B, C, D. So A and B, I have written, A and D are written in the plane. Is written in the plane. And this bold line is above the plane. And dotted line is below the plane. And what does it, this plane means? Plane of the paper. Here is the plane of the screen of your computer or your mobile, whatever. But when we write in a paper, it is the plane of the paper. All right? Okay. Now, how to convert this? Suppose this is, just see, listen here. Suppose this is, we have to convert, you see, conversion of Fisher, conversion to Fisher and vice versa. That means wedge to Fisher and Fisher to wedge. Both. Now, see here. This is suppose your Fisher wedge projection. How to do it? Just as if you make it straight, bring it here, bring it down. So when it downs, A is there on the top, B will come at the bottom. B will come on the bottom. Then you look for the group which is above the plane. Above the plane, where it will go, you see this, when it is there in the wedge projection, this is making an angle here, right? This is making an angle here, which is an obtuse angle. Just bring this one this side. This bold one, the group on the above the plane, you just bring this side. So it comes here, left hand side, and automatically C will go to the left hand side, right hand side. Okay?
Okay, sir.
Okay. Now, suppose you want to go from here to here. I just let me remove this, all this extra lines. Just you want to go from here to here. This line and this line, you just write this way. Suppose A is, you make this in the plane. And
Sir?
then, yes.
In the above structure, we have write D in left, but in the below we write the D on right. Sir, why?
No. I just see. I am that is I am coming to that. Below means here. This one.
Okay.
This one you want to say, no?
Yes, sir. In interconversion.
Okay. Yes. You see, suppose this is your carbon. The compound is bond as a carbon bonded to A, B, C, D. It's not necessary that you have to write A here. Is it compulsory to write A here? Tell me, is it compulsory to write A here? Yes
No,
or no?
sir.
It's not.
No, sir.
It's
No,
not.
sir.
I can write anywhere.
Yes,
That is my
Okay,
question.
sir.
Okay. So I can
Okay,
write
sir.
anywhere. That is not. That can be differentiated from one another by configuration. When we come to configuration R and S, that time we can understand which one is what. But here, just an example I am showing. So when you go from here to here, so what has to be done? This line which are there in the vertical position A and B, they will go and occupy the position in the plane of the screen. And one the group which is there on the right hand side here, because your angle is being made here like this angle. So the group which is there above the plane will go this side. So this group has to be written above the plane, and this group has to be in the below the plane. Now, second example, when I see right here, here what we find here, you see, I am saying that we have to write with an angle this side, and this is above the plane, this is below the plane. But you cannot say that I can write this one or this the one which are the group which are in the plane. I can write this way also. Yes or no? Huh? And
Yes,
this is
sir.
above
Yes,
the
sir.
this is above below the plane. Yes, this is what we are writing. We are writing it this way. The angle is this side. But when you write down this the group which is there above the plane, this time you bring it this side. So I am showing it by this arrow. You bring it this side. So D comes here, C goes here. I think you got it. Huh?
Sir.
And
Yes, sir.
you have to do some practice. You have to do some practice at home, taking some complete example, and then it will be okay. Okay. I'll forward this study material in your Google class. So your Google class is important. Let us see this example. Let us see this example. How can we present this one? So how you see here? Yes? Want to say something? I can write it this way.
Hello,
Yes. Hello.
sir. In the wedge structure below,
Yes.
if we keep B in its position only, we will just press it and we will just fix it in the plane. We will not take it to left. Will it be okay?
No, no, I could not follow because your voice is cracking. So can you repeat your question? Huh? Now you see, Yate, you can write any way you like. Here two notations. I have shown it here that we can write it making the group A here, B here. Suppose I write it here this way. This is C, this is D, and this one is A, and this one is B. Now you tell me how to convert it. What is the molecule? And just how to write. What is this? What is the Fisher projection for this one? Yes, okay, let us do some exercise here. What is the Fisher projection? Fisher projection will go only horizontal and vertical. So vertical, what will be the group here? Which group I should write?
C.
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 Which group I should write here?
Sir,
D.
D. It is D. Which
D.
group? Yeah, which group I'll write here?
A.
A. Yes. A. This is because this is the bold line. It will go this side. And this one I'll be automatically this will be B.
B.
Now suppose I write it a structure like this. This side I say this is C, this is A, this is B, and this is A, B, D. Suppose. Tell me, convert it. What will be on the top?
C.
C.
Yes.
What will be the bottom?
A.
A.
A. Yes. What will be left hand side?
The B.
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 D.
B.
B, sir.
D.
sir. D.
B, sir, D.
Because now you have to see. You see here. Come to this. This is bold line above the plane. This will go where? This will go to this one where this angle is there. So B will come here and D will come here.
D, sir. Yes, sir.
Sir, why B is on the right? I can't understand.
No. Why? That is our convention. You have to follow the convention. What we say, if we write our projection, future projection, or wedge projection like this, these two groups are in the plane, then the other one group is above the plane. This above the plane group will go to the side where this angle is there. Because when we convert it, so this becomes A and B, and D is above the plane, so this will go this side. So D is coming here. Huh?
Sir, I have a question.
Yes.
Sir, when we convert fissure to wedge, then how do we know that one plane is above the plane?
Wait. It to me convert kara. This A and C will be this A and B. Where is this one? This is A. This will be B, right? Below one. And another group is above the plane, another group is below the plane. Where is above the plane, which one will come? Because this is on the left hand side, right? This D will come here. And this D will be here.
Yes, sir. Yes, sir.
Huh? Buji paisa?
Hi, sir.
Yes, sir.
Okay, that is the rule. So we are following a rule. That rule you should not try. Now another question comes. Whether we are doing really correct thing or wrong thing, that one we can understand once we take the take the configuration of the molecule. That means when we go to RS, that time we can understand what we are doing is correct or wrong. You may have a question, why should I take it this side? Yes or no? Why should I take this group which is above the plane to this side? You'll have a question. So that question can be answered once we take the configuration of the molecule. Now, got the point? Yes or no?
Yes, sir.
Yes, sir.
Now, A2 Karasun, A2. Suppose here there are two chiral centers now. Sorry, not two chiral center, two carbon atom, middle carbon. So here we can do it in the same way. This is one. I can take this is the carbon which is there. I mean this one. This A I can write here above this is above. The other one below means which one? This is the carbon. This is the carbon here. So there. So what will be C? C is coming. This angle is this side now. This angle is here. So this C will come this side. That means C is placed here. So this C will be here. Or yet when we take this one, E is here. This is E. And this is this carbon. This is carbon. And this carbon is here. This carbon is here. So E, if E is here, D is coming on the right hand side. So D has to be put above the plane. Yes or no?
Sir?
Yes
Sir?
or no?
Excuse me, sir.
Hello. Go on.
Sir, please can you repeat this one above the concept of above and below for this two chiral center? I'm not getting yet, sir.
It's the same principle that we used for this molecule. This is the same concept. At a chiral center, at a carbon, we have got two carbon. One is here, another is here. So this is the first one. This is our A. The second group is which one? This one, right? So this becomes your in the plane. This is in the, these two are in the plane. Now, which one is C? C is on the left hand side. So because this C, the group above the plane has to come this side because my angle is this side. যত এইটো angle আছে সেই angle এই বস্তুটো আহিব, the one which is above the plane. So C must be placed above the plane. Yes or no?
Yes, okay, sir. Okay, sir. Now I get it.
Now you get it.
Yes.
No. So these are
Yes,
concepts
sir.
which had to
Thank
be
you.
understood. But you see, I can write this way also. I can write this way also. So when it is written this way, what is that? You see, to me, I mean, I got the angle to anaquan plane of. Now I can do it this way also. If I do this way, what is there? A is here. This C is here. Here to B to A because my angle is this side. So the group above the plane has to be the group which is coming here, this side. So B must be in the above the plane, and C will go below the plane. This is only the conversion rule. Okay?
Okay, sir.
Okay.
sir.
So ठीक है, today I mean, we have taken enough time for this. There are, I thought a lot of other things I'll do, but once you understanding part is not done properly, then you will have problem. So here, let me see if I can share this video with you, and video will be uploaded in the Google Class. You can see my lecture again in the Google Class. So your membership or your registration in Google Class is very, very, very important. So the study material also I'll share only in Google Class. So let me stop sharing. Let me. Okay, this is giving another warning to us. So I stop sharing. Now you tell me, have you understood this one? I find only 25 people present. Is it okay? The class is all right?
Yes,
Yes, sir.
sir.
Yes, sir.
Huh?
Yes, sir.
Okay,
Yes,
so because I must get feedback, because online class is something different from your 1:1 class. Here too we can take 100 times this example, we can show it in different way, and then here whatever is there with that resources we have to do it. Anyone connection problem? Could not hear properly?
Sir,
Yes.
so in fructose and in cellulose, the alpha linkage and beta linkage, what's the difference between the alpha linkage and beta linkage?
আচ্ছা ঠিক আছে, তুমি এতিয়া বাদ দিয়া, এইটো there are lots of time we can explain it. এতিয়া যদি সেইটো if I want to start explaining that one, that will take, because that is a and I think you have passed BSc, at least this things you should have done it in your BSc also. তোমার cellulose and starch was there in as part of your BSc syllabus. Was it there or not?
Sir, is there, but in 6M,
We had no class.
Yes, sir.
Acha, ठीक है, but we have also there, it is there, you carbohydrate in details, we do it in 3rd semester. You will do it, and that time you will enjoy this. It's very interesting. We'll do it, because here I cannot just go into elaborate, go in that elaboration here. All right, and once we meet in physical class, that time I can just tell you. Okay, so I end the class here. So but you see, we have to take some extra classes, because this is a topic we cannot just take some extra classes. I will plan out after due. Okay, so other days I will sacrifice, you have to sacrifice some of your time, and I will also sacrifice some of my time. All right. Okay.
Okay, sir. Thank you.
Okay then. Bye.
Thank you, sir.
Bye. Join timely always. Don't miss your classes.